Wärtsilä's latest acquisition has been the inquiry of Hamworthy into the Wärtsilä Group. And I would like to tell you about the effect of this merger and what Hamworthy are bringing into Wärtsilä. We is an environmentally sound solution provider for the offshore oil and gas application. And our offshore products and systems can be divided into what we call the pumping and control flow application. We have safety and emission reduction systems. We have process separations, and we have exploration applications for drilling rigs and seismic vessels. And lately we have also gas handling equipment for the LPG and LNG. But first of all, let's talk about the pumping and control flow application. We have a factory in Denmark, dedicated factory developing and producing deep well cargo and process pumps for the FPSO. Here we have built our dedicated string test tower, which is related to the offshore requirement to test the pump in full length before it is installed at the yard. Our deep well pump is all electric driven, long shafted, where you can see the only extending out of the weather deck is the electric motor, explosion proof motor. These applications can be used for cargo, process, it can also be used for seawater lift and also for firewater pump. Here you will see a classic example of a pump long shafted installed in the caisson just outside of the FPSO hull. The electric deep well pump, we believe, has certain advantages compared to hydraulic pumps in respect of noise, vibration, power requirement, and environmental impact. We have also a factory in Singapore where we are producing inline pumps for various applications here again. This, on the left-hand side, you will see a picture of a pump room system for the Chinese FPSO built in Dalian in China. Here we have a complete firewater pump package, diesel-driven, with our pump in one of the end of the diesel, where the hydraulic system on the other end driving the lift pumps in the hull. In addition to these type of application, we have a variation of different engine room pumps for various fluids and also from different materials. Our pumps especially have the nickel aluminium and super duplex stainless steel material, which is of a high corrosion resistance, obviously an importance for the offshore application. We are also into the valves. This is just a small set of different valves solutions we have. You will see here a complex range of different applications for the pumps with a large variation of the material, hence should be suitable for all sorts of requirements from the supplier. We are also into what we call the safety and emission reduction. In this PowerPoint it's specified the inert gas and nitrogen generators together with what we call the hydrocarbon blanketing system. You know that the inert gas is mandatory on the FPSO. Make sure that we have inerting the area above the oil whenever it is offloaded. The hydrocarbon blanketing, actually on a process FPSO, we are utilizing the hydrocarbon as blanketing and as an inert gas, which means that if we should use the inert gas, it will be emissioned into the air whenever we are loading the cargo tanks again. By utilizing a hydrocarbon blanketing, we are actually having a closed loop of the hydrocarbon gases when the tanks are producing oil and lift, and we are filling the tanks. The inert gas or the hydrocarbon gases is actually diverting back into the process system again. This means that we have an emission-free solution for the offshore application. We are also into what we call the flare gas and VOC recovery plants. We have here a diagram showing that we are taking care of the gas going normally to the flare during the operation phase. We are actually stopping the flare pipe or flare stack, and we are sending the gas into the process system again as long as we are in operation, which means that the flare will be fully closed. We have then a need of igniting the flare whenever that is required. So we have also here a specific ignition system to ignite in any emergency situation. We have a volatile organic component recovery plants, which means that here again the VOC from offloading from the shuttle tankers can be collected and taken care of, and also compressed and made in liquid form into the VOC tank on board the shuttle tanker. This means that the emission to air during offloading a shuttle tanker is also reduced considerably. So again, it is from a emission reduction system. We are marketing this system to the offshore. Finally, on the safety emission reduction, we are delivering LNG fueling system to the coastliners, to the supply vessels, which means that we are swapping the diesel and heavy fuel oil by using gas as the fuel system for the engine. Lastly, on the emission, we have our own exhaust gas scrubber unit, where we're utilizing the seawater for cleaning the exhaust. And this means that we are reducing with 99% the cutting sulfur content, and we also, with respect to the particles, we are mostly removing all the particles as well during this scrubbing process. We have also established our own ballast water treatment. We have two different systems established. One is what we call a non-active system with filtration followed with an ultraviolet treatment system, and one active system, again with filtration plus an electrochlorination treatment in the end. On the wastewater treatment system, we have basically the traditionally sewage treatment system in various sizes and forms. It's a complex and compact unit, and it's also designed to retrofit into existing vessels. On the largest scale for the cruise liners, where the water treatment has a large capacity, we have what we call the membrane bioreactor unit. But we have also here developed a new system, what we call the mini MBR, and this is tailor-made for smaller water treatment systems, such as we have on the FPSO and accommodation platforms. Then on the process separation, we are delivering into the top side for FPSOs and semi-submersibles, what we call the vessel internal electrostatic coalyzer. Here we are actually installing electric coalyzer into the first stage and second stage separator, where by having electric current, the water bubble will increase in size, and by increasing the size it also becomes heavier, and hence they will fall down, and we have a separation which is more quicker in the separator tank. This means that you can either increase your flow through the separator, or you can increase the separation tank itself. When it comes to the exploration application, there is mainly the compressor we are delivering into the drilling rigs and seismic vessels. This is the riser tensioning compressor to make sure that the riser is always in a steady mode compared to the movement of the vessel. And here is an installation of some seismic compressor for the seismic vessels. Sorry. On the gas handling, we have lately had a quite success in what we call the LNG regasification. This is a fairly new market where actually the LNG stored in a traditionally LNG vessel is equipped with a regasification module, which the whole vessel could be close to a terminal and actually can vaporize the LNG in accordance to the demand of supply of gas on land. So this type of market, we have seen a very interesting growth lately, and Hamworthy, prior to be acquired by Wärtsilä, has now 8 contracts in order for the regasification units. We are also into the what we call the FLNG, which is the floating LNG liquefaction unit. This is a process where the capacity of LNG liquefaction becomes quite large. We are now talking about 1 million ton of produced LNG per year, which means that the power of doing such liquefaction is quite large, and we need here to install a gas turbine or any other applicable machinery to drive our compressors and expanders. This can be a typical setup for a sheltered area project where we have installed the liquefaction plant on a flat top barge, and we are utilizing the LNG consisting vessel as a storage for the produced LNG. We are also into the LPG, and you will see here a picture of Sana FLPG. This is the LPG vessel operated in West Africa by Chevron, and here we have actually delivered the butane and propane reliquefaction units for the vessel. And have just 2 short power plants for the onshore application. We are into what we call the mini and small scale LNG liquefaction plants, where the small scale is typically up to about 15 ton LNG produced per day, where the feed gas can come from biogas, landfill gas, scales gas, or coal mines. These units can be containerized, as you will see here, artist impression of, and the final produced LNG will be installed in a vertical tower and hence be trucked out of the plant to the consumer. On a slightly larger scale, what we refer to as a small-scale liquefaction plant, which is up to about 500 ton LNG produced. Here, this is a plant we have installed in Norway, where the tanks is definitely larger, and the transportation of the produced LNG will either go by trucks or actually by smaller LNG vessels. So that was what I had to say on the onshore LNG application. We have, in particular here in the US, a situation where the onshore LNG terminal are actually idling due to the reduction of import of LNG into US. Due to the idling situation, the tanks filled up with LNG is boiling, and today the owner of the gas has no way to take care of the boil-off gas other than sending the gas into the grid line free of charge. So here comes in, and we could install a typical plant like this, which we call an LNG boil-off gas reliquefaction, which means that we actually take care of the boil-off gas. We re-liquefy it and put it back into the tank again, which means that we are maintaining the volume of LNG in the tank still with the terminal idling. So that was what Hamworthy produced into Wärtsilä for the latest acquisition. We believe that it will definitely give value for Wärtsilä, and in particular related to what we call the environmentally sound solution for the offshore oil and gas application.